Assalamu alaikum students. Today we will explain determination of refractive index of liquid using laser. This is the experimental setup for the experiment. As you can see, this is the laser and this laser is emitting a red light. This is helium neon laser. It has got wavelength 532 nanometer. Along with this laser, we have one water bath. This is the water bath. We have kept, as you can see, we have kept a graph paper into it. Along with that, we have one vernier caliper and there is one stand. Along with the stand, there is one mirror, and mirror, as you can see, mirror is kept at an angle of 45 degrees. So what exactly is the experiment? Light is emitted, red light is emitted from this laser. As you can see, light is getting, it is on, light is getting emitted, red light is getting emitted from this laser. Light from this falls on the mirror. As you can see, this is the mirror. So light from the laser is going onto the mirror, and from mirror it is partially reflected, partially transmitted. The reflected light is entering into this water bath and we are getting one fringe. In the light, the lights are on, so we are getting one bright spot and there is one blur fringe around that bright spot. What we have to do, for a particular thickness of the water, for a particular depth of the water, see, this is the scale. I have inserted the scale in the water bath and I am trying to see what is the depth of the water. As you can see, depth of the water is around 1 centimeter. It may not be very visible to you, but depth of the water is 1 centimeter. Students, we can also use this vernier caliper to measure the depth of the water like this. We can hold the vernier caliper and we can measure the depth. See, this is the vernier caliper. We will insert the vernier caliper in the water bath. The vernier caliper is just touching the surface of the water. Then using this vernier caliper, we can take the reading of the main scale. See, we can take the reading of the main scale, we can take the reading of the vernier scale, and it comes out to be 1 centimeter. Okay students, so we have to measure the depth of the water. For a particular depth, we have to calculate the diameter of the ring. What is the principle behind this? The principle is principle of total internal reflection. When the light is entering, when light is getting reflected from the mirror, this is the mirror, when light is getting reflected from the mirror, it is entering into this water bath and bright spot is there. Around the bright spot there is a bright fringe. For a particular depth of the water, we have to calculate the diameter of the ring. See, I will switch off the light and I will try to take the diameter of the light. Now see students, I have switched off the lights. The bright spot is there and we are getting one fringe around that. You can use the graph paper and we can measure the diameter of the fringe. So only two observations. This is very simple experiment. Only two observations we have to do. First observation is the depth of the water, the thickness of the water, and for particular thickness we need to measure the diameter of the ring. That's it. We can see students, we can increase the depth of the water by pouring water into it. We can pour the water and we can increase the depth, and as we increase the depth, there is change in the diameter of the ring. The blur ring is there. There is change in the diameter of the ring. I'll again switch off the light and show you the difference. See students, this is the fringe. I am again pouring the water. And you can see, as I am pouring more water, there is increase in the diameter of the ring. This is the thing. Only two observations. We have to measure. See students, Only two observations we have to calculate during this experiment. We have to keep on pouring the water for a particular depth of the water. We have to measure the diameter of the ring. As graph paper is there, you can measure the diameter of the ring. So only two observations, depth versus the diameter.